Assalamu alaikum, this is Mira Kanaish from PITD S1G1, and today I will be explaining about the project background. This slide is about the project background. Waste management is an important environmental issue today. Many people still find it difficult to separate recyclable and non recyclable waste correctly. For example, some people may put plastic bottles, paper, or cans together with food waste or dirty items. This may cause recycling contamination, which means some recyclable materials cannot be reused properly. This problem can also increase waste processing costs and create more landfill. Landfill waste can harm the environment and cause pollution. Because of this problem, our project proposed a smart waste classifier. It uses AI and image classification to help user identify whether the waste is recyclable or non-recyclable. With this system, user can sort waste more correctly and support better recycling practices.
My name is Kavipriya Loganathan from BITD S1G1 and today I will explain the problem statement and the objectives of our project. Nowadays, waste sorting is still mainly done manually, which relies heavily on human knowledge and judgment. Because of this, waste is often sorted inconsistently and recyclable items may be mistakenly classified as non-recyclable or vice versa. In addition, many people are still unsure about which waste materials can be recycled. This lack of awareness can lead to incorrect recycling practices and recycling contamination, reducing the overall effectiveness of waste management. To overcome these problems, our project focuses on four main objectives. The first objective is to develop a smart waste classifier using image classification techniques. The second objective is to classify waste into two categories, recyclable and non-recyclable. The third objective is to demonstrate how artificial intelligence AI can be applied to solve environmental problems. Finally, the project aims to increase public awareness and encourage proper waste segregation practices. In summary, our smart waste classifier uses AI to help users identify waste correctly, making waste sorting easier, faster, and more accurate while promoting better recycling habits.
For this slide, I will explain how our system works. The system starts when the user uploads or capture an image of a waste item using the web application. After that, the image is sent to our trained AI model using teachable machine. The model then analyzes the image based on important visual features such as shape, color, texture, and material appearance. Once the analysis is completed, the system will produce an output which includes the predicted class, either recyclable or non-recyclable, and a confidence score which shows how confident the model is about the prediction. So, in simple words, the system acts like a smart assistant that helps user identify waste types instantly using AI.
Assalamu alaikum, this is me Faris Omar and now I'll be presenting the methodology of our project. The methodology explains the steps we followed to develop our waste classification system. First, we collected 100 images in total. We used 50 images of recyclable and 50 images of non-recyclable waste. Then we prepared the images by removing blurry, duplicate, and poor quality images. We also grouped the images into the correct categories. After that, we used a teachable machine to train our model. The model learned the difference between recyclable and non-recyclable waste from the images. Next, the train model was used to identify new images and decide whether the waste is recyclable or non-recyclable. Finally, we tested the model using new images and check its performance based on accuracy. This methodology help us to build effective waste classification system. Thank you. Next, I will explain the system implementation of our project. For this project, we use Teachable Machine as our AI tool because it's simple and easy to use. After training the model, we connected it to a web application built using HTML, CSS, and JavaScript. On the upload page, user can upload an image of a waste item through the web interface. The system then analyzes the image and predicts whether the waste is recyclable or non-recyclable. On the result page, the system displays the prediction result together with the confidence score. This allows users to get fast and accurate result in a real time. Thank you.
My name is Jaina Ruth, and now I will explain about the result of our project. Based on testing, our model shows good performance in classifying waste images. For example, a plastic bottle is correctly classified as recyclable with 99.97% confidence. A used tissue is classified as non-recyclable with 100% confidence. Paper and cardboard are also correctly identified as recyclable with around 90% confidence. From this result, we can say that the model performs well, especially when the images are clear and properly captured. However, the accuracy may be affected if the image is blurry or has poor lighting. Conclusion: our project successfully developed a smart waste classifier using image classification and machine learning. This system helps users to identify waste categories more easily and improve awareness about proper waste segregation. It also shows how artificial intelligence can be applied to solve real-world environmental problems in a simple and practical way. For future improvements, we suggest adding more waste categories such as glass, metal, and electronic waste, and decreasing the data set size into to improve accuracy and developing a real-time smart bin system for real-world use. That's all from us. Thank you.